Hello everyone, my name is P. RAVITEJA. I am working as an assistant professor in Triple Department in MLR Institute of Technology. Now I am going to discuss about Norton's theorem. So Norton's theorem is similar to the Thevenin's theorem. So we can call it as Norton's theorem is dual to the Thevenin's theorem. In this Norton's theorem, it states that the two-terminal linear network or a circuit can be represented as a single equivalent circuit. That equivalent circuit consists of a current source in parallel with the resistor. So that current source is called as Norton's current source and that resistance is called Norton's resistance. So what is duality? So in network, our networks, voltage source and current source are dual to each other. So current source is the dual to the voltage source and voltage source is dual to the current source. So there in Thevenin's theorem, voltage source is equivalent voltage source or Thevenin's voltage source is connected in series with the Thevenin's resistance, or Thevenin's resistance is connected in series with the voltage source. Here the duality is there is a voltage source, here current source. There is a resistance, here is a resistance. Both the resistances are same for Norton's and Thevenin's theorem. In Thevenin's theorem, we are connecting in series resistance in series with the voltage source. Here we are connecting in parallel resistance in parallel with the Norton's current source. So what are the steps involved to solve the networks by using Norton's theorem? First we have to follow these steps. So step 1. In step 1, by first open the, as like Thevenin's theorem, open the respective element where we have to find the current. So next step, we have to find Norton's current by shorting the where the open circuited element is removed. We have to short that element and we have to remove that element where we have to find current, then and short that branch. So in this, after that we have to find Norton's current. After that we have to, next step is we have to find Norton's resistance. It is similar like Thevenin's resistance, what we did in earlier in Thevenin's theorem. Here also same thing, we have to inactive the sources. What are the sources are there? If it is a voltage source, we have to short circuit. If it is a current source, we have to open circuit. So we have to remove the sources or inactive the sources and find the equivalent resistance. That equivalent resistance is called Norton's resistance or short circuit resistance, and Norton current is also called as short circuit current. Okay, after that we have to draw the equivalent circuit. This equivalent circuit consists of the Norton's current source in parallel with the Norton's resistor. So again we have in step 1 we have removed the resistor or element in which element we have to find out the current. That element is removed. We have to add this element but in parallel with the Norton's equivalent circuit. So in Thevenin's theorem, what we did, we have removed the load resistance in step 1 and we have added in series with the Thevenin's equivalent circuit. Here in Norton's we have removed the resistance where we have to find the current in element. We are removed in step 1 and we are adding the resistance in final step to the Norton's equivalent circuit in parallel. Okay. See here. So this is I am giving one example. I am taking one example to explain the Norton's theorem. See here, same thing, same circuit I am taking for the Thevenin's and Norton's, because these two are dual to each other. Okay. So here Vs is the source and R1, R2, R3 are the elements resistors connected in the circuit, and RL is the load resistance. Here we have to find the current. So the IL is the current flowing through the load. Okay, to find the current through the IL. So as I said, the steps we have to follow. In step 1 we have to remove the load resistance. Here we are removed, but here we have to short circuit the removed element. By removing the element we have to short circuit that branch. So see here R1, R3 and R2. We have to find the current through the short circuited path. That current is called short circuited current or Norton's current. So that short circuited current is flowing through the R2. So by using current division rule, we can find the current through the R2. So the current flowing through the R2 is the Norton current or short circuited current. So see here, now the value of current I flowing through the circuit is found by the equation, that is I equal to Vs by R1 plus R2 R3 by R2 plus R3, because R2 and R3 are in parallel and this combination is in series with the R1. Then that we have to find current through the supply, voltage supply Vs, that is found by the I equal to V by R. The R is the total combination, R2, R3 are in parallel and R1 is in series with the total combination. By that we can get the total current supplied from the supply voltage source. So after finding the current, total current, we have to find the short circuit current. So short circuit current means the current flowing through the R2. So we already know that the current division rule is found to find it is useful to find the current through the one resistance in a parallel circuit. Here R2 and R3 are in parallel. We have to find the current through R2. So we already know, we are calculated total current. Then we have to find current through the R2. It is given by the total current into opposite resistance of the in which element we have to find current, that is R2. Opposite to that one is R3. Okay, so total current into R3 by total resistance R3 plus R2. By this we can find the short circuit current. So second step is over. Now after that we have to find the Norton's resistance. It is similar like Thevenin's resistance. So here we have to inactive or deactivate the sources. If it is a voltage source, we have to short circuit voltage source. If it is a current source, we have to open circuit. By here voltage, here in this circuit he is given voltage source. So we are taking the voltage source, that's why we have to short circuit. By end terminals where we are removed load resistance, we have to observe from that load terminals. Then R1, R3 are in parallel and R2 is in series. The total resistance or that equivalent resistance or that Norton's resistance, that is R2 equal to R1 and R3 parallel combination, that is R2 plus R1 R3 by R1 plus R3. Okay, as per Norton's theorem, what I said in statement, the total combination, total network is converted into one single current source in parallel with the single resistance. So I already calculated short circuit current and already calculated Norton's resistance. So these both are connected in parallel. This gives the equivalent circuit, and we have to add the element which is removed in step 1. We have to add that element to find the current through that element. So the current flowing through that element, that is IL. So IL is current flowing through RL and R internal resistance are in parallel. So by use here current division rule. So current division rule says in one element in a parallel network, to find the current through the one element is calculated by the total current into opposite to that element by the total resistance. So here IL is the total current, load current. So total current is short circuited current into R internal resistance. Opposite to the RL is R internal resistance by R internal plus RL total resistance. In this way we will find the load current through the load resistor by using Norton's theorem. Okay, we will solve one problem basing on Norton's theorem. So find Rn and In, the current flowing through the and load voltage across the load resistor. Here load resistor is 1.5 ohms and resistors are 2 ohms, 3 ohms, 6 ohms and 12 volt voltage source is given. Okay, so what steps we have to follow? First we have to remove the load resistance. Load resistance means if in any problem we have to consider load where we have to find the current that is considered as load. If any problem he is given 6 ohms is the find current through the 6 ohms by using Norton's theorem, then 6 ohms becomes load resistance. Okay, so I am considering 1.5 ohms is the load resistance. Okay, so I am the first step is remove the load resistor and short that element. So AB, that is shorted path, we have to find current through the that is short circuit current through the AB, IAB or IN. So how to find short circuit current? So we have to find total current, that is the current from the 12 volt supply. So how to find that one? So to find the I equal to V by R. To find total current, I equal to what is V? 12 volts by V by R. R means total equivalent resistance. See here 6 and 3 ohms are in parallel and is in series with the 2 ohms resistor. So it gives the total resistance and V is 12 volts. So what is equivalent resistance? 2 ohms is in parallel with the 6 ohms and 3 ohms. It gives the total resistance. What is total resistance? 4 ohms. So 3 into 6 by 3 plus 6. Okay. 9, it gives the 2 ohms. So 2 plus 2, that is 4 ohms. So R total equal to 4 ohms. So what is total current? Voltage by total resistance. 12 by 4 gives the 3 amps. That is total current. But we have to find current through the 3 ohms. That is the short circuit current flowing through the AB terminals. Okay. So what is short circuit current? So here the current flowing through the 3 ohms. It is found by the current division rule. So we need to find current through the 3 ohms. We already calculated our total current. So we have to find current through the 3 ohms by using current division rule. That is I short circuit current or IAB is equal to or I Norton's current is equal to the total current is 3 amps into opposite resistance. What is opposite resistance? In which element we have to find current? That is 3 ohms. So to that opposite resistance is 6 ohms, means 6 total current into 6 ohms by 3 plus 6 means total resistance. It gives the 2 amps. So that is short circuited current or Norton's current or current through the short circuited element, that is AB. Okay, this gives the short circuit current. So to find the total resistance means Norton's resistance, what we have to do? We have to open circuit the current source or short circuit the voltage source. That means inactive or remove the sources. So here I am removing the 12 volt source. Then what it becomes? By observing from AB terminals, 2 and 6 are in parallel and in series with the 3 ohms. So it gives the I removed voltage source, I shorted that path, and 2 and 6 are in parallel and series with the 3 ohms. So when I already told that when we are calculating the Norton's resistance or Thevenin's resistance, we have to stand at the terminals where we are removed element or removed load. So by observing the terminals, we can easily say that which are in parallel, which are in series. Here 2 and 6 are in parallel and in series with the 3 ohms. So 3 ohms in series with the 6 and 2, and it gives the Norton resistance of 4.5 ohms. After finding Norton resistance and Norton current, so what we have to do in last step? We have to substitute in equation. Then we can find the load current. So by by substituting those values and by we have to redraw the circuit by equivalent circuit, that is current source in parallel with the resistance. So the current source is Norton current source 2 amps. The resistance is Norton resistance, that is 4.5 amps. Okay. So I already told that the element which is removed, that is load, in first step we have to connect in parallel with the equivalent circuit. So load current IL is equal to, so the current flowing through the RL load resistance is IL. So total current is IL. Here again we have to apply current division rule. Means total current into 2 ohms into opposite resistance. So we are finding current through the 1.5 ohms. So the opposite to that one is 4.5 ohms. So 4.5 by opposite 4.5 plus 1.5. It gives the total the current flowing through the load resistor. So to find the voltage drop across the load, that is VL is equal to IL into RL, the current flowing through the resistance and the resistance value, it gives the voltage drop across the load. So this in this way we have to find the current through the load and voltage drop across the load by using Norton's theorem. So in same problem we will do if we did in by using Thevenin's theorem. There is also same answer will come for this problem, because both are dual to each other. Okay, so I will briefly explain here what we have discussed in Thevenin and Norton's equivalent circuit. So Thevenin theorem states that it is possible to simplify any complex circuit into one equivalent circuit that consists of single voltage source and in series with the single resistance connected in series with the load. Okay, so series combination of Thevenin's voltage source V0 and Thevenin's equivalent circuit R. Okay, so in Norton theorem he states that it is possible to simplify any circuit into one equivalent circuit. It consists one current source in parallel with the resistance, okay, and load is connected in parallel with this equivalent circuit. Okay, so in this way we will do problems and we will solve the large complex circuits by using Thevenin's and Norton's equivalent circuit. Once again I am saying that by use these Thevenin's and Norton's circuits are dual to each other. In Thevenin's circuit we will represent all voltage sources into one voltage source and all passive elements into one passive element is connected with the series with the source. But in Norton's, that voltage source becomes current source here, and that series combination becomes parallel combination. So in this current source in Norton's here, current source is connected parallel with the passive element. Okay, so these two theorems are dual to each other. In this way we will solve many problems on Thevenin's and Norton's theorems. Okay, this is for today.